Hi, everyone. My name is Gustavo Durand. I'm at Harvard University. I'm joined here by Jim, one of our community core Dataverse team members. And we're here for a webinar on an introduction to Dataverse APIs. So very quick intro. I'm the technical lead and architect of Dataverse out of IQSS, and Jim is working with the GDCC, the Global Dataverse Community Consortium, as a senior developer and architect. So our agenda for today is we will be discussing a little bit about the what and the whys of APIs. We'll then transition into how it fits into the general modularity schemes that we have within Dataverse. We'll go from there to talking about using APIs and how to make some of the API calls and lots of examples from the guides. Following that, we'll go and talk about some of the tools that use the APIs, including a subsection which Jim will give about the tools for adding many or large files to Dataverse. And we'll finalize by talking a little bit about the front-end re-architecture project that we're working on currently and how it relates to the APIs. Okay, so what are APIs? So API stands for Application Programming Interface. And really all that means it's a way for developers or other applications to programmatically get to making calls within a software. We have here this image, and it shows, for example, the box at the bottom is Dataverse, as it currently is architected. And so there are two ways to really get into the business logic. One is through the GUI, the graphic user interface, but the other is this API. And so you can see there are many different ways the API gets interacted with. On the left, you see there still could be a UI. It's just not the official Dataverse UI. It's UIs that go through these applications that are part of our partnerships and integrations with RSpace, with OSF, with OJS, and they have user interfaces that then talk to the API. Or, for example, lots of times you'll run things from the terminal window, either directly through a script or maybe using some of the tools that we've developed, like the DVUploader, and they also talk to the API. And the end result is that whether you come in through the GUI or you're coming through the AI, it all goes and talks to the business logic on the back end. That said, and we'll get to this at the end of the webinar, but we're working on a current re-architecture where that GUI box, or GUI oval, I guess, will move out of the box and will also communicate via the APIs. But more on that in a little bit. So why is it that you want to use APIs? Well, within Dataverse, one of the things is we have a very broad community. It's open source and lots of different ways, lots of different types, data's users. And so to be able to help the community work with it and develop and deploy Dataverse, we want to enable modularity. We want people to work on different modules of the application, of the ecosystem in ways that don't have to be part of the core code. They don't have to necessarily branch the source code, and they can run the core code with their own modules, and it works for their different users and workflows. We also use APIs a lot of times for having programmatic access for bulk access. We'll see that, for example, again, when we look at the many file uploads a little bit later. And related to that, just interoperability in general with what we call external tools and any other repositories or softwares that want to interact or talk to Dataverse directly. So as I said, the modularity aspect is very important, and APIs are just one of the ways we deal with Dataverse with modularity within Dataverse. So just to talk a little bit about that and just see where it fits into this whole modularity scheme. Like we said, Dataverse software works with different workflows, domains, different organizational models, and we need this flexibility so that different installations can configure it how they need to. In addition, one of the things that was very important when we worked on the Dataverse 4 version is we wanted to make sure we separate out the functionality that was critical for a data repository, namely publishing, versioning, sharing, citing, and allow all the other functionality, the exploration and the visualization, to be worked on in other languages by other developers and to be able to interoperate. So how do we accomplish these different aspects of modularity? Well, first and foremost, the easiest is just via customization. And so the way this is accomplished is with JavaScript. When a Dataverse has an installation, there are ways that they can modify the HTML or JavaScript in custom ways, have a custom header, a custom footer, a custom CSS sheet. They can add some JavaScript functionality. For example, there's the external control vocabulary, and they can customize their installation that way. Additionally, lots of the different aspects of being able to support these different types of users and metadata and workflows and things like that are customizable via database settings. And so, for example, which metadata blocks are in use by an installation or within a Dataverse collection is configurable at the database level. Similarly, the kinds of roles that you have for permissions can be configured at the Dataverse level. Beyond that, this is where developers come in and where more programming happens is we have this concept of plugins that go through what's called the service provider interface. And it's a way that when you have some activity that might have multiple different ways of doing it, you can provide an interface so that you can create new ways of doing that same functionality. The example I always like to give is export. Dataverse core code comes with some standard ways of exporting to Dublin Core, to DDI, and things like that. But there may be exports that are needed specifically for one installation that are not of interest to the entire community. So we enable the installations to work on that via this plugin model in a way that they, again, don't have to fork the main branch, but they can basically run it as a separate WAR file that can provide extra exporters and things like that. And lastly, and the main concept of today's talk, is how we work with the APIs for external systems. So this is where we'll see what we call as external tools. There's a whole section in the webinar about that and how they interact with the Dataverse core to provide some functionality that is, like I said, the exploration and visualization and things like that that are not part of necessarily the publishing aspect of data sets, but are these nice bells and whistles that you really want in an ecosystem of a good repository. Okay, so now we'll go into Dataverse and using APIs within Dataverse. So the first thing I want to start out is just, this is a very important link. If you want to use the APIs, you're going to want to check out this link. This is the link to our API guide. Right there, we see the contents from the top of the API guide. It's going to have an intro and how to get started with the APIs. And in this section, all the examples I will show basically come from examples that are in the guides. There's no way we have time in this 1 hour to go through all the examples in the guides, but hopefully this gives some level of some ideas of the different kinds of things you can do with the APIs within Dataverse. And then for further information, again, you can go into the guides to learn more about the ones we show and the ones that, again, we don't have time for. So how do we access APIs? Now, there's going to be lots of different ways, and we'll talk a little bit about some of the tools that have been developed to access the APIs later, some client libraries. But the most simplest way is really using this tool called curl, and that stands for client URL. All the examples in the guide basically use curl because it's something that can be run from a terminal window. It's something that developers use to try to interact with the APIs and send data and to and from. In general, when we call a curl command, the response that we get will be in JSON format. That's a language that can be easily parsed by machines, but it also can be understood by humans. And one thing just to point out is it is a case insensitive. So in the examples, we're going to see curl in lowercase. Some of the flags that you do provide are case sensitive, but the actual command itself is not. So there's no difference between C with uppercase URL and curl all lowercase. So let's see an example curl API call. And so this is an example. We'll talk a little bit more in detail about what this does a little bit later, but just to see a little bit about some of the components of how it works and how it builds itself up. So the first thing is you call curl. Obviously, that's how you interact with this. And then what we need is an endpoint. So in this case, the endpoint is the server you're contacting, specifically in our case, a Dataverse server that you're contacting. And for our examples, we use the demo Dataverse, so demo.dataverse.org. You'll notice after that, it says API. Again, that's how we build the URL for going to the APIs. And then Dataverses is actually the API we're calling this example. And like I said, we'll talk a little bit more about that with the examples. But the basic idea is you have a URL, which is the endpoint that you're calling. The next thing you need is an HTTP method on what you're trying to do. And if you don't include this by default, the HTTP method is get. And get is the most straightforward. It's used to retrieve information or a resource from the server. It's read only and gets you information. Additionally, you can post things as we do in this example, and that's so to sending some data to the server and to creating a new resource. We'll see that again used in the examples when we want to create a Dataverse collection or create a data set. There's also put, which is most often used when you want to update an existing resource, make changes to something that's already been created on in your system. And lastly, delete is used to delete the resource. The next thing that you may need, and again, this is generally to be used with post and put. You're not going to really have this always with get calls, but you need the body. What is the data that you're sending? And again, it's relevant to post and put because that's when you're creating your resources updating. So you need to have data that you're sending instead of just reading information. In this case, you can see we're sending a file because this is for creating a data set, this example. And lastly, any additional headers you need. As you can see, it doesn't matter if they're at the beginning or the end of the call, but you can see here we have two different headers. One is for the API token, which we'll explain a little bit more what that means in a bit. And then last is what's the content type of the body that we're sending. And so in this case, we're sending a JSON file, so we need to let the API know. And every API will have different requirements for what headers need to be required. And we'll talk a little bit about that as well. Okay, so let's look at some sample APIs that can be accessed for Dataverse. We'll start with some public APIs we have. These are APIs that anyone can access. If you go to the terminal window right now and cut and paste this first command, this curl demo.dataverse.org API info version, or you type it out, you'll be able to run it. You'll be able to see what version the Dataverse the demo is running. There are also some other APIs that we have under the info block. You can see, again, the URL is after APIs info, and that's to be able to get some of the settings that are publicly available. In this case, a couple of quick examples are what are the custom pop-up texts for publishing data sets? What's the maximum embargo duration in months? And so these are things that, as we talk later again about the re-architecture project needed these to be public, and so we make them available via this info/settings API. Not all the settings are available, and not all of them should be available. Some of the settings need to be private for obvious reasons, but any setting that's public will be available via info/settings as we continue on this re-architecture project. And then any other kind of configuration info can be gotten through some of the APIs that exist. We have APIs for getting, for example, what are the metadata blocks that are being used by this particular installation? Or, give me specific info about a single metadata block. I want to know what are the data set field types that are part of the citation metadata block. So that's the last example you see on this page. And so I mentioned that the responses in these are typically JSON. So let's see a sample response. So if I call the demo.dataverse.org/API/metadata blocks, this is what I get back. I got a JSON that gives me the names and details on the metadata blocks. Now, a machine can read this very easily, and that's great. A lot of APIs are built, so machine talking to machine. This isn't super human readable. It's just a little bit of blunked up. So what I would recommend is there are tools that help you. The one I like is called JQ. And all you do is you take the same command and then you can pipe it to JQ, which is something you can do in a terminal window, basically setting the results of one command to another. And then you get this much nicer. It goes ahead and indents the brackets correctly. It puts some color coding in so you can see what the attribute keys and attribute values are. So now it's much easier to see. Okay, we have a metadata block for geospatial metadata, whose name is geospatial. We have social sciences, we have astronomy, et cetera, et cetera. So again, as you're working with the APIs to be able to better human read the responses, JQ or other such tools exist to make that easier. So I mentioned, public APIs, but not all the APIs, and there are many APIs in Dataverse that are not fully public. In this case, what you're going to need is an API token to access them. And so an API token is similar to a password. It allows you to authenticate your Dataverse software with the Dataverse software, and the API then performs actions and performs it as you. So it's something that you want to keep very private. You don't want it to reveal your API token to anyone, just like you wouldn't tell anyone what your password is. And because there are over 100 installations of Dataverse around the world, your API token only works on the server you're accessing. So, for example, this token that I'm about to show how you get only works for demo Dataverse. In fact, it doesn't actually work because I already revoked it because, I didn't, again, as I said, you don't want to tell anyone what your token is. But when it worked, it only worked for demo Dataverse. If I tried to contact Harvard Dataverse or QDR with the same token, it wouldn't work. It's, they're different servers, they're different websites, they have different user accounts. And so the way you get an API token is right now you do that through the UI. You go in, you click on your user information, you click on the API token tab, and you can see when I first went in there, it says API token has not been created. And so you just click the create token button, and there you have a token, and it expires. And our current expiration for tokens, they're long-lived. They last a year. At that point, you would need to recreate a new token. And so you can see the token is just this string of alphanumeric characters. And usually what you'll just do is you'll cut it and you'll paste it into your commands. Okay, so let's talk about some of the more interesting APIs, both public and private. The very first one and very useful is the search API. So the search API exists. It supports searching the same data that you would through the UI. It has one required parameter, which is the Q parameter. So here we see the most simple search. We're searching demo Dataverse for any objects, whether they're data sets, collections, files, that match the search term messy. It would return a bunch of results, but maybe we want more specific information. So we do have the ability to add optional parameters, which will allow you to sort, allow you to facets, because the facets allow you to highlight why it matches your search results and other such operations. So here's a couple examples. The first one, we're still doing the same query of messy, but now we're saying, go ahead and let me know why you matched those results by saying show relevance equals true. So besides just giving you the results and the response, it'll also tell you why they matched. And tell me what the facets are so that, again, if I were writing a UI using this API, I can then say to the end user, well, maybe you want to narrow it down by only ones that have this keyword or that keyword. And in fact, in this query, we are narrowing it down to only things that were published in the year 2022. Now, this result, you see, there's no API token being sent. And so you'll only get public information. You'll only get things that have been published within Dataverse. But you can actually also search unpublished content that you have access to. But to do that, you have to pass that API token that we generated. So here's our first example showing how we pass in the API token. You can see here we're using a header. The -H represents the header. And the header is just x-dataverse-key. And then you can put in the key. Now, in all the examples here we have, and just to make it simpler and to make it obvious that we are using a token, this is the way we're passing the token. There is a more secure way of passing a token where you don't actually have it in the command line that you're calling, and that way it's not kept in your history and things like that. So I would recommend looking in the guides on how to do that as you're using the APIs more and more. But like I said, for simplicity in the applications, I'm just including it as part of a header here. And so in this example in the search, again, we're doing the same search query, but this time we're limiting it to just data sets and only ones that are in the Dataverse collection Argentina. And so, like I said, there's a full flexibility of what you can search in the UI, and that same flexibility is replicated through the API. Okay, so now let's talk a little bit about access APIs. The basic access API is API/access/data file and what the ID is. When you see the $ in the guides, that means it's a variable and you would replace it with something. So a few examples here. To download a single file, you just call that API, and instead of ID, I replace it with 10. When we're using in the backend Amazon, it's redirecting. So we need to use the -L modifier, curl-L, to be able to tell the terminal window to redirect to the Amazon bucket. We can also add a different header to only get a range of that file. So in this case, we're only getting the first 10 bytes, 0 through 9, by adding the range colon bytes header. We can actually download multiple files at once. And you'll notice this is actually a slightly different API. Instead of being API/access/data file, it's API/access/data files. It's just one character on the screen, but just on the back end, it's a different method that gets run and treats it differently. So in this case, we pass a comma-separated list of IDs. And one thing you'll notice also, we have another flag, which is output arg.zip. Now, the reason we put this is because if you don't do this, it'll just return the results on your screen. And in the first case, when I was just doing a file, that might be okay. Maybe I'm only looking at a text file and it's okay to get the results in the terminal window running. But generally, you're going to maybe want to save that file if it's a binary file. And we know when we do multiple files that that's definitely a binary file. So this is the way we can specify, go ahead and don't show it to the screen, but save it as a file and use the name arg.zip. And then the last example is downloading all files from a data set. Again, it's going to be a zip file. We see the -L again for redirecting. And here's another way to get the file. Instead of saying -output and specifying the file name, you can just say -O and -J, and that will use whatever file the server is telling you it knows the file to be called. And so in this case, it'll call it, a name representing the data set. The one other thing we see here is rather than pass an ID, since data sets have persistent IDs always, we're passing in the persistent ID. And we have to do a little bit special way there because since the persistent ID contains slashes, we have to first say, this is going to be a call using the persistent ID. That's where you see the colon persistent ID. And then we pass the persistent ID as a parameter using the !mark persistent ID. Okay. Now, again, besides just searching, we can deposit things in the Dataverse. We'll see some tools that are using these APIs a little bit later. But so here's an example of creating Dataverse collection and one of depositing a data set. You notice again, now these are, instead of get API calls, they're -x post. And so we're posting new information, and we have a body, the upload file. The second one actually is the one that we saw in our sample when we were looking at the components of the API call. So we've seen that one before. So, but it's that simple. You just call the API, you tell it what the upload file you're uploading is, and you make the call. Now, these upload files obviously have to exist before you make the call. And so just to see a couple examples, here is a sample JSON for the Dataverse collection that we were creating. Just very simple, just, contains the different attributes, the name, the alias, the context, then, the things that are required. If you didn't pass this in or didn't pass this in with the things that were required, for example, let's say you didn't include alias, instead of getting a success created, you would get an error saying required field missing, things like that. Here's an example of shouldn't say collection. It should just say data set sample JSON. And you can see it's ... at the end because the file is longer than a simple page, but it gives you an idea of what it would look like. You're passing information about the author in this case, and the title. Okay. In addition to these APIs, we have several different administrative type APIs. And so I've broken these out into 3 groups. The first is ones that regular users can do. And now it's a user who actually has a Dataverse collection or a data set. You have to have the right permissions. If you try to call this and you don't have permission, you're not going to be able to do, it'll again return you an error, a 403 forbidden error. But in this case, assuming you have the right permission for your data set, here's an example of listing the role assignments within the data set. And similarly, we have deleting a Dataverse collection. If I'm the admin of a collection and I want to delete it through the API, I can just call it's the same API that I would call if I was doing other operations, but in this case, I'm passing it the delete HTTP method, and the API knows that this means I am deleting this. And of course, our regular logic exists. You can't delete a published Dataverse, but if it's a draft Dataverse collection, then that can be deleted and you would get success. There are APIs that only super users can do. So these are, for your curators, if they want to be able to configure a data set to store all the new files in a different file store, this is the way they would do it. We do offer this as well through the UI, but this is a simple way to do it. Again, programmatically, let's say there are 20 data sets that they need to change this for. Instead of having to go through the UI, click, 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 they can, create 20 versions of this call, changing the different data set IDs and run it. And you notice this is our first example of a put, again, because it's not creating a new resource, but it's updating information about an already existing resource. And then the second example is user management. If you need to change the identifier of a user, in this case, for example, we're changing Messi to Lionel Messi. This is the API you would call for that. Lastly, administratively, we have some APIs that are only for installation administrators. Now, these we require to be extra secure, and so we actually cannot call them directly from the terminal window on our laptop. We have to actually log into the server that's running the software, and assuming we have that access and that privilege, then we can run them there. They typically don't require an IP token because these are not really actions that are user actions. They're more system actions. And so here we see a couple examples, how to reindexing a data set or how to delete cached metric results. They're both under the API/admin group, and that's because, again, they are restricted to being on the local server. And you notice, again, that's where you notice the URL has changed. Instead of going to demo.dataverse.org, because we can't do it from our laptop, we actually are logged into the machine and just calling localhost because we're calling it directly from the machine we're on. And again, we'll see another page of contents of the guide in a second, but there are lots and lots more APIs. This is just a quick overview of some examples. But some of the other API groupings that I really would like to highlight is there are APIs for migrating. And the reason I highlight these is because we have the native migration APIs for JSON and DDI import, but we also support this SWORD API standard. And this is an interoperability standard created 15, almost 20 years ago. It stands for Simple Web Service Offering Repository Deposit, but it's an API that other applications already know how to talk to. And so it's a way that we could easily support things like OJS being able to deposit into Dataverse, for example. The metrics API is an API that exists. We use that to power dataverse.org/metrics, and it provides counts of downloads, datasets created, files uploaded, etc. So we added that in a more recent version in 4.9, I believe. And so if you have a Dataverse installation that's running 4.9 or later, we can now call your APIs. And that's what, again, we use to power our metrics page on our project website. And then another API set that relies on another standard is the idea of harvesting. This exposes structured metadata via this standard called OAI PMH, Open Archive Initiative Protocol for Metadata Harvesting. And basically allows different Dataverse installations to talk to each other or Dataverses to talk to other installations that support OAI PMH in order to harvest and make metadata discoverable. I mentioned earlier that all our examples are using curl and using from the command line, but as you're working on tools that want to call the APIs, you're not going to necessarily want to call them directly through scripts like that. You're going to want to use a programming language that works best for you, either because that's what you're experienced with, or that's the language that will work best for the functionality you're trying to accomplish. And so several wrappers have been written around the APIs, client libraries for these different languages. And you can see the list here, but it includes C, includes Java, PHP. Python is a very popular one, obviously. It's called PyDataverse. And that way, instead of having to call the APIs directly, you actually use regular Python code and make these calls, and they internally call the APIs. So I'm going to end this section just again with showing the link to the guides. This is your literal guide to everything related to the APIs. I chose a different screenshot. Here I'm choosing the native API contents, and you can see there's more at the top and more at the bottom, so it's just part of it. But this shows, for example, how extensive the APIs are and all the different kinds of things you can do with the data sets. Okay, so now we will transition to the next section, which is let's talk about some of these tools that use APIs. So in this case, you're not going to be doing things from the command line directly, unless that tool is a command line tool, and there will be an example of that when we get to Jim's part. But they are tools that wrap around those APIs for you. So as I mentioned earlier, we have this concept in Dataverse of external tools. And I like to break it out into 3 different kinds of tools. It's either tools that talk to Dataverse, basically they are read-only, or excuse me, they write into Dataverse. And they generally will be using the deposit data API. We're going to see examples of that when Jim goes through his talk. They don't require anything special to be set up in the Dataverse because you're starting on the external application and doing everything there, and it's talking to Dataverse. The user doesn't necessarily interact with Dataverse in that context. The second one, though, is tools that Dataverse does talk to. And so in this case, you're starting on Dataverse and you're directed to that external tool. So in this case, we need a manifest file, and we'll talk a little bit about that in a second. These have either predefined areas in the UI where they'll plug in, or they're actually just embedded directly in the AP in the Dataverse UI, which is what the preview query tools. And we'll go a little more detail about all these different kinds of tools in a second. And lastly, there are tools that do both. So the second set, those were the read-only tools. These tools that do both, again, you'll start at Dataverse, you'll click a link to get to this tool. It's a configure tool is what we call it. And when you do something there, what happened is it'll want to send something back to Dataverse. So this will need an API token that has write privileges, just like the ones that talk to Dataverse. These are read-write tools. So I mentioned when you're using the second and third kind of tools, you'll need a manifest. So this is how you basically express to Dataverse, hey, this tool exists. Here's a description. This is what kind of tool it is. This is how you get to it. And these are the parameters it's going to need in order to be able to talk to your API. So in this case, it's going to need to know a file ID because it's going to want to download a file, and it's going to need a token to be able to download that file. And when we talked about those different administration APIs, that is actually how you upload this tool. There's an API that uploads the tool, takes the JSON file, the file similar to this one, and uploads it. And once you run that API, that external tool will now be available in your Dataverse installation. So let's see some examples of some of these tools. The first is we have an extensive set of file previewers. And so this is a set of tools that display the contents of files, allows them to be viewed without actually downloading the file. You can see here on the right, I'm showing you the example of the image previewers. So on the top, you see that's just the Dataverse dataset listing of files. But if I were to click on the file itself to go to the file page, I see this preview, and that I see a fully expanded version of the image that I'm looking at. A couple more examples, but on the left, we have a PDF file previewer, and on the right, we have one for tab files. And the one thing I'll note on the tab files, you'll notice there's an extra button that says File Tools. That's because you can upload more than one previewer, and you can have multiple previewers for different types of files if you want. There'll be a default one, which is the one that shows, but if you were to click on that button, you would see, oh, I can also preview it in this other tool. And the last previewer that I just want to briefly touch on is the zip file previewer. And the reason is because you'll notice there's a plus in the title, and that's because besides just being a previewer like all the other ones, it actually does a little bit more. It uses that range functionality that I showed earlier in the Access API so that you can use this to actually download individual files. And you can see, for example, on the right, there's all the little download buttons. So this way, instead of having to download the entire zip, you can preview the zip and say, oh, I only want to download the third file or the fourth file, things like that. Okay, so I said I'd mention a little bit more about Explore tools, Query tools, Configure tools. First, Explore tools. They provide the visualization and statistical analysis type tools. On the right, you see an image of Data Explorer. And so Data Explorer is a tool written in a different language, and it talks via APIs to Dataverse to get the information it needs to be able to display this. We've recently added Query tools, which are trying to leverage the new AI technologies, ChatGPT and things like that, so that maybe you can ask natural language questions of your data table's contents and get information that way. And then lastly, we have the configure tools, which are the ones that when you download or when you go to them, you read the file, but then you make changes there. You're modifying metadata or things like that. And then you're sending that back to Dataverse. Besides file level external tools, we have dataset external tools. So a common use case for exploring files is, you know what, I don't just want to look at one file. I need the whole set of files of a data set because I'm trying to reproduce the results of the data set. So in that case, we need dataset level explore tools because you want to explore all the files. And a couple examples of that we have linked up with Wholetail and with Binder. And they both, in order to create reproducible research packages or custom and computing environments and be able to, again, reproduce the data that was in the data set. And a recent addition is this idea of configure tools at the dataset level. And so why would you want that? Well, the example and the reason we added it for the moment, and hopefully more tools will be coming soon, but is this tool called Kirby Curator, which is out of ICPSR. And it is also using AI technology, and it's providing recommendations to enhance your metadata and generate meaningful titles, descriptions, and keywords. We actually had a community call on this last month. It was very interesting, and if you go to dataverse.org community calls, you can find the video and the slides for that. But I think it's an exciting use of AI to improve your metadata and pass it through and see what it recommends and see, yes, that's actually a really useful keyword, a really good description for the data set that I've just uploaded. So next, we will talk a little bit about tools for adding many and large files to Dataverse. And for that, I will let Jim do the talking while I will still drive the slides for him.
Okay, thanks, Gustavo. So the use cases where you might want to use these tools in the normal Dataverse UI, you can upload, I think by default, it's like 1,000 files at a time, but there are various cases you can see here. One is just when that list of files in your browser is getting very long, you might want to use a different tool that makes it easier to see how your upload is going. Certainly for large files or slow networks where uploads are going to take a long time, Dataverse can now handle keeping files in subdirectories when they're in the data set. And so having local subdirectories where you've got your files in a directory tree, if you want to keep those paths when you put them into Dataverse, you can't do that through the normal UI, so you might want to use one of these tools. Similarly, if you're working with a set of data where you've got things in a directory tree, and every few weeks you're adding files in there and you'd like to periodically upload only the new files to Dataverse, these tools might be useful. You can include or exclude files with a given name pattern. So if you've got some test data mixed in, or you don't want to upload JPEGs and only the other files in the directory, you can do some of those things. If you simply want to automate the transfer because you don't have a human on the other end, it's actually your program that wants to be doing uploads and downloads, so you've got an instrument or whatever, and you want to just automate the transfer, you can use these tools. And similarly, if you're working on your local desktop, but you're actually computing on a cluster, and you don't have a browser over on the cluster, but that's where the files are, you can use these command line tools to send the files to Dataverse. Okay, go ahead, next slide, Gustavo. So the three tools I want to talk about are they have some different pluses and minuses, so it's not quite a Goldilocks situation. And I think depending on what you're trying to do, all three of these could be the best solution for you. The first one is actually something that works like the external tools that Gustavo was just talking about. It's a web application on its own, and it interacts with Dataverse. It does have to be configured by the admin on the Dataverse you're using, but once it's that, you're just basically clicking buttons, and I'll show you details in a moment. The next two are command line tools. You have to download the tool in either Python or Java for the first and second one there. And basically you give a list of files and they do the upload for you. The last one I'll point out there that I call this the ugliest, and I can get away with that because I was the person who wrote it. But it really has been partly a reference implementation that anytime we add new APIs and things to make uploads more efficient, we've been trying it out in DVUploader. So it's sort of the oldest, most complete, most configurable options for you, but it also has not been cleaned up to make it a very nice interface. So it just streams the input out, and I'll show you an example in a little bit. Just to point out at the bottom there, all these tools, Dataverse has gotten more efficient at doing uploads of large things over time, and one of the ways that does that is to use S3 storage and something called a direct upload to the S3 store. The first two of these tools, I think, only work with S3 direct upload storage. The last one can do both, but really if you're in the game of large files or lots of files, you want to be using that. And so you should look for a Dataverse that has that supported. And the second thing to point out is that these tools, everything they're doing is basically the API. So you can use these tools, or you can go under the hood and use the same API calls they're doing if you wanted to do this on your own. Okay, so next slide. So for the DVWebloader, there's a 55-second video that I'll let Gustavo play in a second. But basically what's going on here is this is the Dataverse dataset web page. Our normal web page for this, we'll scroll down in a minute, you'll see an upload button. And if the DVWebloader is installed, one of the options will be upload a folder. If you click that, it will pop up in a new window. You get a button and a dialog to select a directory you want. There's a required security pop-up from your browser that says, do you really want to let this tool upload things from your local disk? And if you say yes, it'll basically show you the list of the files in that directory. By default, it will not upload files that are already in the data set and will only upload new ones, but you can click checkboxes to say, yes, I want to upload this file and not that one. You click start upload, it'll start doing its thing in the background. When it's done, it'll give you a green success symbol and say, go back to your dataset page and refresh, and you'll see the file. So Gustavo, if you click the button, we'll actually see all that stuff happen. So this data set has one file in it that we'll see down at the bottom here. There's our file. We'll click upload and then upload a folder. There's a select directory button, click, and I've picked a directory already. So there's my dummy directory. You don't have to see the details here. There's the warning dialog that you have to accept. There's the list of files. The first one was already in there, so it's not selected. I'm going to deselect another one, click start uploads. It'll take a little while here. These are small files for the example, so it's pretty fast. When it turns green, we'll close this, go back and look at the data set and scroll down. Once we refresh the page, there's all the files. And then the last thing is just in the video is just going to the tree view so you can see that the directory structure is actually replicated in the data set. So that's how this tool works. And again, it has to be set up by your admin, but once it's set up, you basically just use it like the normal UI. Go ahead to the next slide. Next one is the Python DVUploader Python tool. So you have to get Python, get the tool itself. The earlier slide where I listed the tool names, those things are links in the slide deck. Those are links to the GitHub repository where you can find the tools themselves and get the things you need. So, and they have more details about how these things work and how to set them up and so on. The two tools that are command line tools basically both do essentially the same thing. You call the tool, so it says DVUploader, you give it some files or directory that you want to upload. In this case, it just files here. And then the things you have to do is just like in the normal API, you have to tell it which data set by DOI that you're actually talking about, give it your API token that shows that you have permission to upload things to that data set, and you have to tell it which of the 100+ installations in the world that are running Dataverse that you're going to. With this tool, there's an alternative. Rather than having to do sort of the individual file names, you can put all that stuff in a config file. And with that option, in addition to uploading the files themselves, Dataverse keeps lots of metadata about files. So anything from the directory path we've talked about to a description of the file, category tags, whether the file's restricted, those sorts of things. So with a config file, you can actually set that metadata at the same time as you're uploading the file. And if you click the button for this video, again, not much to see here other than it's pretty. It'll start running. This is an example where it's a config file that's running. You can go ahead and hit the button, Gustavo. It's reading. There's 3 files in here. You're going to see it. There's a small, medium, and large file. So you can see the large file takes the longest to upload. At the end, it's got to tell Dataverse that all the files are in place. And once it does that, it'll end in 5 seconds from now. We're going to see the end of the video. Your files are uploaded and you're good to go. And if you went back to Dataverse, you'd see that. Okay, so that's all that's there. So next slide. Last one, the DVUploader here. Again, you have to have Java installed. You can go to the GitHub and get the jar file. And you can see from the one command line there, it's basically the same information. You say, Java, run this jar. Here's my API key. Here's the DOI for my data set. Here's the server I'm going to, and here's the directory I want to upload files from. When you do that, you can see what I mean by ugly on the side over here. It's basically you get a long streaming list of, it's trying to look through these files. It's finding the ones that exist, and the ones that it doesn't find, it processes and uploads them and tells you their hash values and moves on. So you just get a long stream of that, but all your files get uploaded essentially the way that the earlier tool did. That list of options there, at one level, you can just look at that and say, gosh, there's lots of options. So that's one takeaway. I'll try and go really quickly through a couple words on each just to give you a sense what's available. But list only will let you tell the tool to go look, and it will tell you what it would do, but it won't actually transfer anything. So you can make sure you're doing what you think. You can limit it to doing 10 or 100 files at a time. You can give it those regular expressions of which files to exclude. Verify will actually make sure that the hash value of the file in your local system is the same as the one that's up in Dataverse, so that you can verify it's essentially the transfer went correctly. Recurse will let you either take the top level directory that you have or all the subdirectories and pull all the files out of all the subdirectories. The max lock thing is something that helps this work with older versions of Dataverse. You can force it to use the old and less efficient way of uploading files to the server rather than to S3. You can tell it to trust self-signed certificates, so you can work with demo instances of Dataverse where you haven't gotten a real certificate, et cetera, et cetera. You can skip files so that if you've already uploaded the first 1,000 files and they're good and you don't want to see a stream of I found this file, I found that file showing up, you can skip through. If you want to re-upload files that have the same name as ones that are already in the data set, you can tell it to do that, et cetera. In addition, this has a detailed log file, so it has essentially the same information here, but if there are any things that go wrong and there's like exceptions and stack traces and so on that are good for debugging, they'll go into that log file. So this is, again, a tool that's useful if you're struggling to get things to work and you want to work with the Dataverse admins or the community. We'll want to see that log file. It might help us help you. The last little point I'll put on there is that Dataverse also has a mechanism that we haven't talked much about today of being able to export data sets into a research data alliance conformant archival bag, where this one zip file includes all the metadata and data that's required to create an individual data set. DVUploader is the one tool we have right now that's sort of a proof of concept of being able to, if your Dataverse went away and the database went away and everything, and you had to recreate the data set, you can take that zip file, run it through DVUploader, and it'll recreate the data set back in the Dataverse. So not so relevant for uploading files right now, but just to give you a sense that this is a reference tool where we're trying out the new things you can do in Dataverse or in this tool as well. Okay, so next slide. Just a couple things to finish up. These things are using the direct upload API, and Gustavo showed you an earlier one where the normal API, you would basically make one call to Dataverse and say, here's the bytes that I want to post. Here's the metadata about the file, and in one call, you'd have the data set in Dataverse. The direct upload is a little bit more complex to make it efficient, and the mechanism basically has three parts. First, you tell Dataverse, you make an API call and say, I'd like to upload a file that's this many bytes. And Dataverse will give you a set of signed URLs to talk directly to the S3 store to upload that. So if you're not familiar with signed URLs, the idea is essentially that normally you would not be able to read or write from the S3 bucket that Dataverse is using, but Dataverse is able to give you signed URLs that temporarily grant you permission to upload just that one file, just for that one data set, just for the next 30 minutes, 1 hour, 2 hours, and then you lose permission. So if you get those URLs, you can basically upload the data set. S3 is also very nice for large data because it, for larger files, it can actually allow them to be uploaded in multiple parts. So for example, a 1 gigabyte file could even be like 205 megabit parts. And so Dataverse will give you a list of 200 URLs where you can upload all of these individual parts. That's efficient both because you can do them in parallel and because if you have a failure on one of those uploads, you only have to re-upload the 5 megabytes and not start over for the whole gigabyte file. With the multi-part, you have to upload the parts and then basically you get one more URL that you either abort it or complete it at the end. Once you've done that upload, the file is in S3. Dataverse hasn't put it in the data set yet. And so the last call you make back to Dataverse is to give the metadata for that file and tell it, you're essentially telling Dataverse, hey, the file that I put in S3 at this location should have this name, this description, has this hash value, please add it to the data set. So if you do those three parts, you're essentially doing what those tools I just talked about are doing. There's a new option that if you have, for example, 1,000 files you're doing this for, you can do the first two to get all the 1,000 files in place, and then you can make one call to Dataverse and say, here's the list of 1,000 files. And so rather than having Dataverse update the data set after every file, you just do 1,000 at once, more efficient. The last thing that we haven't talked too much about with Dataverse is data sets do have the idea that one file can be replaced in version 2 of a data set with a different file. You can also do that with the direct upload API. So won't say anything more than that other than if you need to do that, it's available in direct upload. Okay, next slide. Just a couple of notes about doing this. In general, handling larger files and more files, you know, we've over the years made this much better in Dataverse, but it still requires the Dataverse instance to be configured appropriately. There are timeouts. They're just having enough disk space or enough space in S3 allocated to do it. So if you're the person in a given Dataverse instance who's got the biggest files right now or the most files or you're on the slowest network, you could be the one to run into those sort of configuration problems that you'll have to work with the admins to kind of get things configured correctly to make it go. And I think once you do it, or once somebody has pushed that boundary, things have looked like they work very well. But if you're kind of the first person through for a given Dataverse instance, you may be the one to walk into these things. The other thing is if you're uploading terabytes, you know, there's a cost for the people who are running the thing, and if you upload terabytes and don't tell them, even if it works, they might be surprised and unhappy to find out that there's new costs all of a sudden. So the short version of that, if you're doing things that are kind of outside the bounds of what you see in a Dataverse, talk to the admins first. It'd be helpful for you and for them. Second thing, we've seen issues where people try to run multiple copies of these, and one reason they do that is because they're trying to make things go faster. So if they figure more of these are running at the same time, that'll help. These things already parallelize uploads, so it actually won't help. Don't do that. The other problem is that all of these tools, the way I've talked about them, if you've been listening closely, you might hear they all check to see what's in the data set to decide what's new that has to be uploaded. And so if there's another tool running at the same time that's changing what's in the data set, you can have errors that you don't want to get. So just run one at a time. Again, keep you out of trouble, and also you're not going to get any benefit of going faster if you try to do that. Last helpful hint here is I used to work more in supercomputing, and if you say gigabytes and terabytes are large data, you get laughed at. So if you really are talking about big data and you're talking petabytes and beyond, Dataverse also has equivalent kind of functionality connected to Globus, which is a large data transfer standard. Or it has this ability to basically reference data that's at remote sites, whether that's a Globus endpoint or it's at a separate web server or something. So if your data is actually too big to transfer, again, I would look into those other APIs and those kinds of things to do that. Last slide, just quick acknowledgement and ask for help. These tools are all things that are supported by multiple grants and projects within the community. Some have been individually supported by multiple things. You can see people and places here, but all of them are open source. They're on GitHub. We welcome contributions from anyone, either reporting issues or fixing and extending them. So again, these have been really community efforts to keep them up and going. And if you want to join in, we'd be happy to have you. All right, thanks. I think back to you, Gustavo.
And so the last thing we'll talk about really quickly is the front-end architecture project. So basically the idea is that we are separating the front end and the back end applications. And so, like I said, in that initial diagram, we had one box where both the UI and the API were part of that same box. The UI will now go outside of that box. The back end, therefore, will be API first, Dataverse backend, and the front end can be the single page application outside of that core Dataverse. And the benefits of this is it's going to allow us to modernize the front-end technologies. We're using React for this new single-page application right now. We're able to speed up development for new UI, UX ideas because it will release on a different schedule because it's effectively a different application. And those things will empower the community and will extend the modularity, which we saw is important for supporting the open source community. The key point how it relates to here is because, again, the front end now will be the separate application. That means anything that it wants to do in Dataverse will have to be functionally available through the API. So all the functionality that's available through the UI that the Dataverse project provides will be available through the API. And so anyone else would have access to it through creating these tools, running through the command line, all these things that Jim and I talked about. And our initial plan is to release a beta version of this in the second quarter of this year. So stay tuned for more news on that in the upcoming months. So thank you so much. I hope this was all very useful. Lots of information. Again, go to that link in the guides to see more. And the one plug I'll put is in March, we have our annual Dataverse community meeting. It's being hosted by CIMIT, which is a group in Texcoco, Mexico. So if you want to come and learn more and meet in person and talk about it in person, that's a great opportunity to meet not just us, but also hundreds of members of the community who all gather yearly. Thank you very much.